Hello, friends. Welcome to the ATC Double Cut. My name is Micah Woods, and in this episode, we are going to be discussing the growth potential, the temperature-based growth potential from paste turf, and how to calculate that accurately. I have, over the years, calculated this myself thousands, maybe millions of times. And I have also seen a lot of other people calculate it. And occasionally I have seen some people make some errors in the calculation. I want to explain as easily as I can what some of the common errors tend to be. And I will point out a particular one that I was made aware of last week. Of course, this was an error that I had seen before, but what happened was one of the Paste Turf members contacted me and said they were using the Paste Turf weather prediction to look at what their upcoming forecast growth potential was, and it was a certain value. And they were using another service that also was calculating GP, and the value was completely different. I'm talking about a difference of 40% or so. And so one of those was giving a reading of, or a prediction that the growth potential would be 20%. And the other service was giving a prediction that the growth potential would be about 60%. And the question sent to me was, is the paste turf growth potential calculation incorrect in this case? Is there a bug in the software? So naturally, I checked that right away, and I found out no, the paste turf growth potential calculation was being made correctly. So it's the other calculation that must be in error. And I did some diagnosing and found what I think the problem is, and I will explain that in this blog post that, let's see. There we go. I want to bring up on the screen the way I want this to look so we can see it clearly. For those of you watching and for those of you listening, I will describe what we're seeing. And for everybody, I'm going to put a direct link to this post with the title Calculating GP into the show notes. This one is a 2-minute read on the ATC website, and it starts off with this paragraph. It says, the paste turf temperature-based growth potential, or GP, is a utility function that takes the input of average air temperature and gives an output of GP, or growth potential, on a scale of 0 to 1 or 0 to 100%. This isolates the potential effect of temperature on turfgrass growth and conveniently expresses that potential on a scale we can all understand. It turns out that this simple growth potential equation comes into use all over the world, and it turns out to be really useful because we can compare growing conditions all over the world, all on the same scale, whether you're using Fahrenheit or whether you're using Celsius degrees for temperature, or if you happen to be using Kelvin or some other degree scale, you can express it on a 0 to 100% basis in terms of how close the actual temperature is to the optimum temperature for turfgrass growth. And it is something that is quite simple. And then it allows people in the UK or in Australia or in Canada or in the United States to say that their growth potential was 50%, or their growth potential was 10%, or their growth potential was above 80%. And we don't have to worry about the exact temperatures. We can just express everything in terms of something that's similar to what the grass may be experiencing. This is not an episode about all of the many, many uses of growth potential. If you want to check that out, I recommend clicking on the growth potential button that's right at the top of this blog post. So the blog post has a title of Calculating GP, and if you go under that on the website, you see a growth potential tab. If you click on that, it brings up all of the posts on the ATC website that are tagged with growth potential. So you can find many, many uses of that. But I want to talk here about the equation. And I don't show the equation. I try to avoid showing equations. Actually, I try to avoid talking about equations also. I'm going to explain it very nicely here. I'm going to explain it very clearly so you can understand where the error came from. But, people don't really want to look at equations too much if we're doing a video podcast or if we're doing a blog post. These are all available embedded in some spreadsheets or embedded in some PDF documents that are available on the ATC website or on the Pace Turf website. And if you want the definitive equations, which are based on Fahrenheit degrees and are also available to calculate for Celsius degrees, you can get those from the Pace Turf website from what are called the climate appraisal forms. And you don't need to be a Pace Turf member to access those, although I recommend Pace Turf membership because it is a valuable resource for getting all kinds of information that is useful, applicable, and practical. And it's guided by the insight from Doctors Larry Stoll and Wendy Gelernter and myself. Some people have asked me, why can't I just look for information on Google? And I kind of chuckle and I think, are you serious that you think the information on Google, some of it you're going to find is going to be excellent, but some of it is not accurate. And what you have on Pace Turf is something that is basically, to use the term peer reviewed, it's peer reviewed by myself and in the past by the founders of Pace Turf, Larry Stoll and Wendy Gelernter. So something that's developed by professionals and checked by professionals and experts in this field. And of course, you can go to Google and check for yourself, but some of the information on Pace Turf is better and more accurate than what you can find from Google. So that is my explanation for one of the many valuable things about Pace Turf. All right. So we've got these equations. The equations are designed to do something very simply. And what that something is to take the input of actual air temperature, specifically the average air temperature for a 24-hour period, and convert that temperature into a growth potential. So the input to the equation is the actual air temperature. The output of the equation, or the output of the function, is the growth potential. And the growth potential is on a scale of 0 to 1, or multiplied by 100, it's 0 to 100%. There are a few constants that go in the equation, and then there's just that one variable. The one variable is the actual air temperature. The constants in the equation depend on a couple of things. The constants are the optimum air temperature. That's one of the constants. The optimum air temperature depends on whether we are working with, whether we're going to be adding into the equation the variable of Celsius degrees or Fahrenheit degrees. So are we going to be giving the actual air temperature in Fahrenheit? If so, we need the optimum air temperature to be set in Fahrenheit. If we're going to be adding into the equation Celsius temperatures, then we need the optimum air temperature to be set in Celsius degrees. That's all fine. That is to be, I think everybody kind of understands that. I'm not aware that anybody's made the error of leaving the equation with an optimum temperature set in Fahrenheit degrees and then using input of Celsius, or having an optimum temperature in the equation set in Celsius and using input of Fahrenheit temperatures. That doesn't make sense, and I think that's an uncommon error to make. So those are a couple of constants. Then those constants vary depending on whether we're using a growth potential equation for cool season grass, which has an optimum air temperature of about 68 degrees Fahrenheit or 20 degrees Celsius, or whether we're using the growth potential equation for warm season grass, which has an optimum air temperature of about 88 degrees Fahrenheit or 31 degrees Celsius. So you can see that we've got a cool season GP equation and we've got a warm season GP equation. And those equations have different optimum air temperatures depending on whether it's warm or cool, Celsius or Fahrenheit. That is pretty straightforward. But here's the error that I noticed last week, and it's an error that I've noticed before, and that is the variance number. The variance number is basically just to fit the shape of the curve. And the growth potential, if you plot on the horizontal axis, if you plot the temperature from freezing up to a very hot day, which would be over 100 degrees Fahrenheit or more than 37 degrees Celsius, if you look across that range, growth potential is a curve. If you plot the growth potential for every single temperature that you could possibly have on the planet Earth, you would get a curve because it is peaking at a high level at close to 100% when the temperatures are close to an optimum for the grass to grow, and then the growth potential goes down as we move far away from the optimum growth temperature. So I made a chart to show what the error was, and I'll bring that up on the screen. And let me make sure that's still showing. And I'm just tinkering around with this for those who are watching this. So if you're listening, I'm now showing a chart on the screen. The chart has a title, Standard versus Erroneous GP. And this is posted in the gallery of the Pace Turf website. On the horizontal axis is the average air temperature, and it goes from 20 degrees Fahrenheit in this case, which is maybe 6 or 8 degrees below 0 Celsius. And it goes up to the optimum air temperature of 87.5 exactly Fahrenheit, which is about 31 degrees Celsius. And there's two lines on this. There's two lines that I plotted on this chart. One line is the green line, and the green line is labeled Standard Pace Turf Equation. And the growth potential is 100% when the temperature is in the high 80s. Why don't I just stick to Fahrenheit for now? Usually I have a tendency of using Celsius degrees or using some of the metric numbers. In this case, I'll ask my listeners from around the world to humor me, and we'll just talk in Fahrenheit since that is what this chart is labeled in. So this is for warm season grass. This is plotting the warm season growth potential, and it goes down to about 50, and when the growth potential is reaching close to 0, that's at about 50 degrees Fahrenheit. That's about 10 degrees Celsius. And then when we get down to 32 degrees, which is freezing, the growth potential has already been indistinguishable from 0 for about 18 degrees. If the temperatures are in the 30s, if the temperatures are in the 40s, warm season grass is not growing, so the growth potential is 0. That's the way the standard equation works. On this chart, I also have a red line that is labeled wrong equation. And the only thing that I've done with this wrong equation is I have set it to take input of Celsius degrees. I have also set it to have an optimum temperature of Celsius degrees. But I left the variance number, or the shape of the curve fitting number, the same as it is on the Fahrenheit scale. And because the scales are different for Fahrenheit and Celsius, the variance constant, it's a constant in the equation, but the equations need to be adjusted whether you're working with Fahrenheit or Celsius. And specifically, I recommend a value of 7 if you're using Celsius degrees for warm season grass, and I recommend a value of 5.5 for Celsius degrees for the variance if you're doing this for cool season grass. Those are the specific numbers. I don't want to get too deep into the details of equations here, but this is something that is available on the ATC website, and I would think anybody using the growth potential equations should check that however they're calculating it, that they are getting something close to the number that you get from the standard pace turf equations. So what happens is if you use the Fahrenheit numbers, which are 10 and 12 for the variance, and instead of 7 and 5.5, if you use those larger numbers for the Fahrenheit scale with the Celsius input, you will end up with curves that don't have the proper shape. The curves will not be, the curves on the growth potential line, the temperature scale, the temperature line, those values will be incorrect as you move away from the optimum temperature. The incorrect equation and the correct pace turf equation are going to give exactly the same number if you're at the optimum temperature. But then as you move away, those will no longer be correct. Let's see. I'm just checking what's showing on my screen for a minute. And I think we're correct. Yeah, there we go. Okay. I want to point out one more thing, and that is there is a post on the ATC website that explains the variance exactly and just what that does in terms of shape of the curve. If you scroll down to the bottom of this post, I put this in. I said, for more, see the related posts below along with these links. What is the variance in the growth potential equation? And if we go to this post, for those of you watching, it might be useful to see this. For those of you listening, there will be a direct link. Well, you can get this from the show notes. I will make sure that there is a direct link to this. So the title of this chart that I'm showing is Effect of Changing Variance in the Growth Potential Equation. And I show that as you increase the variance, so if you make the variance 15, you get something that you could go to a freezing air temperature and you'd still have a growth potential of 50%. Or you could go to you could set the variance at 10. This is with Celsius, and it should be at 5.5 for Celsius. But if you leave it set at 10, you go down to a freezing temperature, and you're going to still have a growth potential close to 20%. And the growth potential is supposed to drop more than that. If you set it just at 5.5, you're going to get something that is almost exactly the same as the pace turf original equation. And if you set the variance smaller than the recommended value, then you're going to get something that drops very quickly as you move just a small amount, a few temperatures away, a few temperature units, a few degrees away from the optimum temperature. So that's something that everybody should be familiar with, because we want to make sure that when we're talking about growth potential and when we are comparing growth potential and looking at growth potential from one season to the next or from one location to the next, that we're all talking about something close to the same thing. So this is something that I have encouraged people more and more to try to stay close to the standard equations. It's something I've admitted that myself in the past, I would sometimes say that the growth potential is just a model, it's just an equation, and if you can adjust the equation so it fits more closely the way grass actually grows at your location, then have a free-for-all. Go ahead and change the equation however you like to change it, and have your own growth potential. But I realize now that kind of defeats the entire purpose of it. And if you're going to do that, I would recommend calculating the standard growth potential side by side with your custom growth potential. Use your custom growth potential, your unique growth potential that better fits the way grass grows at your site. Go ahead and use that, but keep it to yourself. When you're sharing information with other people or asking questions about how things relate to growth potential around the world, use the standard one, because otherwise we're all speaking in a different language. If you set the optimum temperature to be 64 degrees Fahrenheit instead of 67.5 degrees Fahrenheit, and then you start saying your grass is growing this way at a certain growth potential, well, you might be the only person. I was saying that you might be the only person in the world who knows what you've used for the optimum temperature, and therefore you might be the only person who knows what your GP actually means. When you're trying to use it for comparison to anybody else, to anybody else's growth potential, it just is not going to be the same, and you're not comparing apples to apples anymore. So I recommend using the standard equation for anything that happens outside of your own operation, for any comparisons to standards or things like that. You can find a bit more about growth potential and adjustments if you click on that growth potential tab at the top of the blog post and scroll down and find some of the posts that are related to that particular topic. I'm going to be back again soon with more interesting turfgrass topics. For now, I will sign off for ATC from Trang, Thailand. I'm Michael Woods. Bye-bye.